This project is called the Joule Thief. This is the breadboard prototype, and then this is the final PCB device. And the purpose of it is to power a 2.8 volt LED here and here. And it requires minimum 2 volts to run, but the purpose is to turn it on with a spent 0.7 to 1.1 volt battery. First of all, to prove that these two batteries here are actually 0.7 to 1.1 volts, I'm going to show that they can't power this Xbox controller here. And you can also see a photo of a DMM here. So now I'll go here, and it turns on, and then it turns off because there's not enough voltage to keep it on. As seen here, this is the breadboard prototype of this circuit here. So you can see the two ends of the toroid inductor here connect to the positive terminal, and then the other two, the blue and the black one connects through this cable to the negative end of the white LED here, which is also in parallel with the collector pin of the 3904 NPN resistor here. And then the other end of the inductor comes out and connects to a 1K ohm resistor, which then connects to the base pin of the 3904 transistor. And then as for the other two ends of the transistor and LED, the positive pin of the LED is connected in parallel with the emitter pin of the transistor, which are also connected to the switch on the three-way switch, which is then connected to ground. Then when it's turned on, you can see the light turns on with just a 0.9 volt battery here. Now this is the final PCB here connected to a spent AA battery here. So it's the same thing, LED, just three-way switch, 3904 NPN transistor, 1K ohm resistor. However, the inductor is in a different form. Instead of having one large toroid, you have two 100 microhenry inductors here that have the same effect. So then when it's turned on, the LED obviously comes on. When the electrons come in, they power a few come through this 1K ohm resistor and open up the transistor from the base pin. And then once that happens, more electrons start coming through now that it's open and start to build up every time the transistor turns on and off. So it's similar to a regular switch. As that happens, the electrons build up here, create a voltage higher than 0.9 volts, in this case, minimum 2 volts, because we know it's minimum 2 volts because the white LED is turning on. And then they come all rushing out through the LED and then back to ground. And this process repeats around 100,000 times per second. To show a practical example of what's happening with this LED and how it's flickering 100,000 times per second, this is the same effect on a LED alarm clock with a transistor inside. However, this is flickering much more slowly than the breadboard prototype, so this is visible on camera, whereas this isn't.